Hello, welcome to the CS475 Project 7A. I've done some refactoring of the code that was provided and done some improvements to add some interesting features. We'll start with the OpenCL part. I've implemented a function that says generate color from bounce, and it has a parameter of angle, and the angle is a 0 to 2 pi, and this is kind of a three-phase function. So even x, y, and z, which is actually RGB, but for ease of coding, I just picked those letters. So you have an angle of 0, an angle of 120, and an angle of 240. And as particles bounce off of the incident object, they'll change color. So also I've changed the gravity coefficient to negative 1.5 instead of 9.8. It was mostly for graphical effects and not trying to model any kind of mathematical system. Let's see what else. Oh, here we go, bounce function. I added a coefficient of 2.05, and what this does is when a particle bounces on the incident object, it increases in velocity. And so the idea of the simulation is there's a sphere of particles inside of a bigger sphere. And whereas the original project had the particles bouncing off the exterior, these bounce off the interior. So we have so some simple controls here. Click, left, right controls, I guess we'll say the Y vector. Up, down controls the X vector, but you'll reach a gimbal lock if you try to do this at an axis. It's because we're not using quaternions. It's, I didn't really feel like I needed to dig that deep into the code. Although it would have been cool to do it, but I didn't quite have the time. And then right click, up, down, will zoom in and out. So you can do some pretty cool things, but you will reach gimbal lock if you go here. Up, down doesn't work, so you gotta watch out for that. Alright, so we have this guy. We have a ball inside of a ball with a negative 1.5 gravity coefficient, and the particles change color upon impact with the outside sphere. So we'll hit go. Oh, also the initial velocity was the normal based on 0 vector to position, so they all expanded outwards at the same time. The idea was to model some kind of wave function or particle acceleration inside of a contained volume, which yields some interesting results. You start getting these like sine and cosine functions inside of itself. And so the interesting problem with this is as velocity increases, you wind up getting an anomaly based on the... We'll go over here and then scroll this up a bit. Based on this function here. So the bounce function will set the out vector to the n minus n, which is the velocity. Yep, here. Times the coefficient and the dot product. So as this increases, you're not setting the position of the particle based on the impact. You're setting it based on the delta t. Delta t is 0.5. So as it increases in time, you're not getting the accurate result. One way to fix this would be to find the time in which the particle hit the outer shell and then use that position to calculate the velocity inwards. But, again, time encoding. Takes a lot. So as we reach critical velocity here, it's going really wild, and the particles will eventually start spewing out because the velocity left versus right, up versus down is too much, and they all sort of start shooting out. And then you can still see the sine wave functions as they shoot out, which is quite interesting. And then they're all gone. All the particles reached maximum velocity. So if this was a containment experiment or a radioactive or electromagnetic kind of field analysis, we would say that it did not pass. But it's a parallel processing thing, and I feel like it's pretty good. Thanks for watching.